Let's look at question number 5. In the illustration ABCD, that is ABCD, VEDG and EFGH are all squares, and the side length of each of the square is 1 unit. That is, AC is 1 unit, CD, DG, GH, HF, etc. are all 1 unit each. And if the angle ECH is alpha and the angle FCH is beta, calculate alpha plus beta. And what is also given is alpha and beta are positive, that is, they are measured counterclockwise. First, let us look at the limiting values of alpha and beta. Now, in a square, the diagonal is pi by 4, that is 45 degrees, correct? So, alpha and beta cannot exceed 45 degrees by construction. If it is 45 degrees, all the squares will come together, they will overlap each other and they will be sort of concentric. So, there will be only one square. And if it is 0, if alpha and beta are 0, you will have just a straight line. There will be no more squares. So, the limiting values of alpha and beta are 0 and pi by 4. That is, alpha and beta lie between 0 and pi by 4. Let's write down the condition. Alpha is less than pi by 4. Beta is also less than pi by 4. Therefore, alpha plus beta is less than pi by 4 plus pi by 4 equals pi by 2. Therefore, alpha plus beta is less than pi by 2 and it is also greater than 0. So, alpha plus beta lies between 0 and pi by 2. This is a very vital information which we will use later. Let's come to the solution. Now, I am going to use the tan alpha plus beta formula. Tan alpha plus beta equals tan alpha plus tan beta whole thing divided by 1 minus tan alpha tan beta. Now let's calculate it, tan alpha and tan beta. Now tan alpha would be EG divided by CG, correct? EG divided by CG. EG is 1 unit. CG is CD plus DG, that is 1 plus 1, 2 units. So 1 divided by 2. Similarly, tan beta. Tan beta equals FH divided by CH. FH is 1 unit. CH is 1 plus 1 plus 1, 3 units. So 1 over 3. So we will plug in these values here and calculate. So this will give me tan alpha is 1 by 2 plus 1 over 3 whole thing 1 minus 1 over 2 multiplied by 1 over 3. So this will give me 2, 3. Take 6 as common denominator. So this will give me 5 by 6. Okay. Now 6 again as common denominator. So we will have 6, 6 minus 1, 5, 5 by 6, which equals 1. So tan alpha plus beta equals, looks very familiar, right? Very simple answer, correct? Okay, what we will do is, we will give a more mathematically rigorous answer. So for that, we need to look at the behavior of the tan function and look at the value of alpha plus beta in this interval 0 and pi by 2. Okay, let's do it in the next screen. The key to understanding the behavior of a function is to look at the graph of a function. Here I have displayed the tan function in the interval minus 3 pi to plus 3 pi, and we are looking to solve the equation tan alpha plus beta equals 1. The graphical method to solve tan alpha plus beta equals 1 is to look at the line alpha plus beta equals 1 and where all it is intersecting with the tan curves. As you can see, the line alpha plus beta equals 1 is intersecting the tan curve at multiple points, indicating there are multiple solutions to our equation. The line alpha plus beta equals 1 intersects the tan curves at pi by 4, 5 pi by 4, 9 pi by 4 in the positive direction, and minus 3 pi by 4, minus 7 pi by 4, minus 11 pi by 4 in the negative direction. And in general, alpha plus beta equals pi by 4 multiplied by 4 plus 1, where n is set of all integers. So that's the general solution to our equation tan alpha plus beta equals 1. However, in our question, alpha plus beta is in the interval 0 and pi by 2. And the only point where alpha plus beta equals 1 is at pi by 4. So the solution to our question is alpha plus beta equals pi by 4 or 45 degrees. And the same can be written mathematically as follows. Tan alpha plus beta equals 1. Therefore, in the open interval, in the open interval 0, pi by 2, alpha plus beta equals pi by 4 or 45 degrees. So this is the regular solution to our equation tan alpha plus beta equals 1 for this particular situation. Let's get to question number 6.